Oops. As quick as anything can be. Oh, do I want to use purple? It's so freaking aggressive. Lost all my markers. Blue works. Yeah, I do want it. Alright, it doesn't matter, it's okay. So, if I wanted to represent 3, blue, you're cool. 3 plus -5. With a set model. Try to do that. So, just to show you, so for 3, you can just use 3 pluses, is that cool? If you don't have a black and red marker. I don't, so I'm going to do the same thing. I'm curious, we'll eventually see how these two are different. I think everybody in here would agree they have the same mathematical answer, but they have different ways of thinking about them physically, right? Those two. So who thinks they have 3 plus -5? Got it. What did you draw?
3 plus signs and 5 negative signs.
Yeah, so if you have 3 plus signs, that's 3. And then you add in 5 negative signs. And of course, what's the one thing you do have to take a moment to explain to students when they start doing this? What immediately happens up there?
The positives and negatives cancel out.
Yeah, these 3 cancel. So then you can see the answer. That. So what is that? That's -2. Okay. Now this, of course, is understandable, where parents will not understand that the work is different for these two problems. We understand that we're trying to get students to go from physical to conceptual, and it takes them a while. So these two physically are different. Does anyone have a clue how to do this problem? Basically, you got your turn.
Yeah, I know.
So let's work it out. What do I draw to start with?
It is 3 pluses.
3 pluses. What is this asking me to do?
Put 3 -5s.
Nope, that's not.
It's take away 5 positives.
It wants me to take away 5 positives. Is that cool? So that was very different from this. This said to add 5 negatives. Very physically different. So this is the thing that parents don't get. We got to bridge the physical to the conceptual, and that is not something you do overnight. You really want that bridge to be strong. Children grow up and they get counting really quickly. They like counting because then they can keep track of what they got and so forth. But to go from this is the same as that, that's a huge conceptual leap. So the main problem is, let me give myself a little more. The main problem is, if I want to take 5 away, I don't have 5. So what did we do to overcome that?
Put a plus and a negative.
Yeah, so if I introduce some zeros, so now how many pluses do I have total?
4.
4. Now I've got 5, correct?
Well, you introduced to make that.
Exactly. So I introduced 2 zeros, which didn't change anything. Math is looking as like, all right, whatever you want to do, human. It's the same shit. But now what can we do officially? We can do what this tells me to, right? Find 5 pluses and take it away. So then I'm left with -2. Cool. Now, do you see how visually these are incredibly different? Do you see that? This one has 3 pluses and 5 negatives. This one has 5 positives and 2 negatives. I mean, that's very different. So it's, from a physical standpoint, it's not immediately obvious that these are actually the same. Now, if you do enough of these and you start getting the same number, our pattern seeking takes over as humans. And we're like, okay, there's a pattern here. Why are those the same? Okay, I like it. key. Okay, there is, so let me show you kind of a way to bridge these a bit. Alright, so this is a perfect way to do this. If I ask you to represent these two things, that's exactly what I want to see. Let me show you something that's kind of silly. 3 plus -5. So if I have 3, and then I add 5 pairs. So I didn't do anything, correct? I added 5 pairs, right? And then I could add, this is really silly, but then I could add 5 negatives. There is a way to kind of make these physically look the same. I'm not even gonna do it, it's just really silly. No change on that. Okay, so that's one thing we did. We looked at, first thing we actually did was talk about physical, kind of like imaginary situations, where somebody could kind of have it in their head what plus and minus means. So like digging a hole, climbing up a ladder, money is good, right? Unless you're really young, then they don't know money, so you need something else. You guys kind of with me? So one way to think about it is negative is digging the hole, and positive is climbing up a ladder. So if I have -2 minus 7, I go dig 2 feet down, and then I dig 7 more feet down. A kid can figure out you're 9 feet down then. They can see that in their head. And like, this is not me telling you you should do this in your backyard. I want your parents all up on business, don't do that. But I mean, it's something they can actually visualize. Okay. So that's part of what we talked about. Division got interesting. Let's see if you guys are cool with this. Well, multiplication was pretty straightforward, except for the fact, so let's do a multiplication problem. If I want to do this, it literally is just, if I want to do a set method, I would just make 2 groups of -3. So that's -6. That's pretty straightforward. What was the difference here, though, physically? So here, real quick, isn't that where I started on this problem? I drew a circle. Then I introduced 2 groups of -3, because this says add 2 groups of -3. You guys see that? Because that's a +2. So I added 2 groups of -3, and then I can see the answer is -6. This one says, start with nothing. Now do what?
-2.
Take away 2 groups of 3. Do you see that? So again, how do I take away 2 groups of 3 when I don't have anything?
You give yourself something to
Yeah.
take away.
So I give myself 2 groups of 3 legally, which means I add 0 many, many times. So now I got 2 groups of 3, and now I can take them away. And what am I left with? -6. Now, you guys understand how, on one level, all you're doing is multiplying -2 times 3, whoop-de-doo, amazing, right? So if you tell somebody, I multiplied -2 times 3 today in class, it's like, good job. But, I mean, this is pretty cool. I mean, I don't know how many of you guys would have thought to do this visually, just given this. But does everybody kind of get that? That's physically what this problem wants me to do. Okay. Which is really freaking nifty. Okay. Let me make sure I don't forget anybody. How much did we do? Oh yeah, that was in the next section. Multiplication, division. We talked about multiply by -1. We talked about negative exponents. You guys already knew about negative exponents. What did we do? Oh, that's the most we did. That's right. And then when we talked about this idea that -1 to the 11th power.
It's odd numbers, so it's going to be -1.
Yeah. So if I have 11 things, my fingers in my nose, these 5 negatives kill each other. So you have 1 negative left over. So this would be a -1. So -1 to any odd power is negative. So can anyone tell me the sign of this expression? It's going to be negative or positive.
Positive.
How many negatives are right here?
2.
No, all right, so there's 2, 3, 4, 5, 6. That's even. Every pair kills each other, so this is going to be positive. I don't care what the number is, because all I want to care what sign was going to be. I guess every pair of negatives are going to kill each other. So if I have an even number of negatives, they all pair up and kill each other. So I had a total of 6 negatives, correct? So these 2 kill each other, these 2 kill each other, and these 2 kill each other. So of course the answer is going to be positive. Positive what? I don't know, whatever the hell it is, but I know it's going to be positive, yeah.
So if it was everything there except Q, it would be a negative, because that just changed up the whole thing into 7 minuses, right?
Oh, if I do what now?
Like if you take the.
This away?
Yeah, and put Q, like put a 3.
Oh, put a 3, okay.
Yeah, it would automatically.
Now it'd be negative.
Alright, cause.
Yeah, because now I got 1, 2, 3, 4, 5, 6, 7 negatives. 6 pair up and die, and then there's 1 left over, right? Okay. Sole survivor, exactly. Lone wanderer. Okay. Negative whatever the hell it is, okay. All right, we talked a little bit about that fact. I like it. We talked about the fact that multiplying negative is actually rotating, right? I think we did that, didn't we? Yeah. So multiplying by a negative is just rotating around 0. I think I've talked about that before, but I can't remember.
And then you try explaining about that we're actually a 10th dimensional being.
No. There's the imaginary line here. So if I go a quarter of a turn, that actually is the square root of -1, but we're not gonna do that. That's where imaginary numbers come from. Okay. So, that's chapter 8. Get in there and try that out. Here's one little thing I'm gonna tell you. Some of you guys I just gave homework back. I just wanted to get as much back as I could. I didn't look at your part A's, right, for most of you guys. So if there's nothing marked in your section A, it's because I didn't look at it. You with me? You can actually get all the answers to those in the back of the book, right? So you can kind of check your own stuff. For chapter 8 and chapter 9, just to kind of make this easier, you just have to do part B, the section B. You with me?
So B for section 8 and 9?
Yes. And I will tell you this. Okay, so we're done with 8 unless there's any questions from chapter 8. Okay. Section 9.1 is funny to me. Section 9, can somebody tell me this? Have we talked about this? What is a rational number? Does anyone know? What's the root word of rational?
Ration?
It's
Ratio.
I'm pretty sure.
What kind of number would you call a ratio?
Other kind of numbers?
What kind of number would you call a ratio?
A part of a part or a whole.
True, so what kind of number is that?
Fraction.
Fraction, I love it. So rational number is another name for fraction, correct? Section 9.1 is hilarious because it just repeats the fraction section again. But now they call them rational numbers. Just to make certain, I looked through really quickly. I didn't see anything that was really new, which means I'm going to make that extra credit. So you don't have to do section 9.1 homework because we've already done it. 9.1 is fractions. They just call them rational numbers now. And I thought for sure I called them rational numbers before, but blah, blah, blah. Okay, so it's got all the same stuff we've done before. It's got, when you divide rational numbers, you reciprocate the second guy. Are you guys kind of with me? Nothing new there. So there's no reason to, do it. Section 9.2 introduces irrational numbers. So we're going to talk about them a little bit. What are irrational numbers? Does anyone have an example of one? You got one, Mason? Pi. Pi is irrational. So let me ask you real quick. We've talked about this before. Does anyone remember what, I can't remember if we did exactly this one, but can I make that into a fraction?
1/9.
close, it's 1/9. And real quick, do you guys remember when we did that, we set it equal to x, and then we did 10 times that? Yeah, remember that process? So any decimal that has a pattern to it, that repeats, can be made into a fraction, correct? A rational number is any number that can be represented with a fraction. So is 7 rational? Totally, why? 7/1, kick out, 14/2, whatever. So 7/1. Yeah, so every integer is rational. Correct? Okay. So rational numbers just adds the idea of fractions. Is this rational? Yes.
Yeah,
It can be written as a fraction. So what kind of decimals cannot be? So any decimal that stops, can you write that as a fraction?
Yeah.
Shit, yeah, that's the whole idea. If it stops, I know what place it's in. I could do over 10,000, over 100, whatever, correct? If it doesn't stop, that's where things get weird. If it's got a pattern to it, bless you, I can do that process we did. I can make it into a fraction. So what kind of decimals cannot be represented as fractions? They can't blank, won't blank. They can't stop, won't stop. And they can't repeat. So if I have a decimal that does not stop and it does not repeat. So pi is a perfect example. That's 3.141596, blah, 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 blah. That's as far as I got it memorized. Because my brain is full. That's all I can do. You guys kind of with me? So any number that can be written as a fraction is a rational number. Any number that doesn't, any decimal that does not repeat and has no stopping point. It doesn't stop, it doesn't repeat.
So is it non-terminating?
Any non-terminating, non-repeating decimal. Yes. Non-terminating. Like good of self-terminating. Any non-terminating, non-repeating decimal. Those are irrational. Does anyone know anything else besides pi that would be irrational?
1/3 of the decimal?
Say again?
Is it 1/3 for 1/3?
1/3 is 0.333333333.
Oh, but is it dropped out because it's not connected?
No. So any number that can be represented as a fraction is rational. So any fraction you can imagine is rational already.
But the 3 goes on front?
Yeah.
But what we just said was, if it's repeating, I can make a fraction out of it, therefore it is rational.
Oh, if it doesn't repeat.
If it doesn't repeat or stop, if it doesn't stop and it doesn't repeat, that is irrational.
So the 3 repeats.
So that's rational.
Oh, okay.
Yeah.
But it's not because it goes.
Very quickly, if 0.1111 is 1/9, what's 0.22222?
2 9.
And what's 0.33333?
3 9.
3 ninths. But you already know it's 1/3, don't you? But 3 ninths reduces to
1/3.
1/3. Yay, okay. Sorry, just wanted to close that loop. So here's an example. Square root of 2. The square root of 2 is irrational. There's no pattern to it. It's 1.414, blah, 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 blah. It's as much as I memorize, it's as much as I need. You guys semi with me? Any square root you cannot do. Like what about the square root of 16? Is that rational? What is the square root of 16? So that's rational. What about the square root of 17? Irrational. I can't do that shit, so it's irrational. Yeah. So the best way to describe irrational numbers is to give some examples of them. So here's a description. Whoa, here's a description. Non-terminating, non-repeating decimals. That's very non-satisfactory. Okay, what this should say. So an example would be pi, square root of 2, any square root that I can't do. Does anyone know E? E is a number like pi? I love it. Somebody's like, E's a letter, Jeff.
They use it in physical science, I just don't know.
Yeah, totally.
Yeah.
It's population growth and decay. Like how long is it going to take Chernobyl to not be radioactive? You use E to a power to represent that. Yeah, that would be this decay slope like this. Yeah, okay. We're not going to suddenly, don't worry, we're not going to do that. Okay, we're not going to suddenly break into physics. You guys kind of with me? That's the irrational numbers. So when I describe this to a group of students for the first time, I say, you start with whole numbers. You start with natural numbers. 1, 2, 3, 4. That's what came naturally to us. Then you add the idea of 0. Then you add the idea of negatives. Right? Whole numbers, integers. Then you add the idea of fractions. And over here would be the weird irrationals, right? And then all of this stuff is in the real part. And over here you have the imaginary stuff, which we'll leave alone for now. That's just a really bad name. They're not imaginary. They exist, right? They're not in a movie with Ryan Reynolds. The imaginary numbers, we could not have electrical stuff without the idea of voltage, which is represented with imaginary numbers. So it's, anyway, sorry, this is much I'll say. Has anybody ever heard of imaginary numbers besides just for me? A little bit, not much, no? What the hell? Please, dear God, stop talking about, okay. Thankfully, the section's titled The Real Numbers, so we're not going to talk about imaginary more than I already have. In this section, they introduce the idea of square root. So let me talk about that a little bit. We just did the square root of 16. Why is the square root of 16 4? Why is the square root of 16 4? Yeah, because it takes 2 4s to multiply by 16. So let me see if you guys are with me on this. A square root cuts a number in half multiplicatively. So if I just ask you what's half of 8, you would say 4, correct? Half of 8 is 4. You guys with me? Because that normally means, cutting in half normally means additively. So if I cut 8 in half, 4 plus 4 is 8, so half of 8 is 4. If I cut a number in half multiplicatively, it's the same idea, but with so 9 is 3 times 3, so half of 9 multiplicatively is 3. So what a square root does is it cuts numbers in half multiplicatively, right? So really, when you see this symbol, you're thinking to yourself, what do I multiply by itself to become what's inside? So what would the square root of 25 be? 5. Holy shit. Yeah. I don't think they go too much deeper than that. Oh, they do that. Okay, I like that. Ah, cool. I'll be all right. Okay. One step up. What do you think this means?
Cube root.
What's the question it's asking us? So this one asks me, there's an understood 2 here that we don't write because we want to save some time. So it's the most commonly used root, so we just don't write the 2. Cube root. So this means, what does it take 2 of to multiply 25? This obviously must mean, what does it take 3 of to multiply by 8? And what does it take 3 of to multiply by 8? 2. 2 times 2 times 2. 8. You guys kind of with me. So again, it cut 8 up. Can you factor 8 for me?
2, 4.
Yeah, 2 times 4, so 2 times 2 times 2. Is that cool? Now take 1/3 of these. You see there's 3 2s? Take 1/3 of them. What do you get? 2. Hey, sweet. So it means 1/3 of 8 multiplicatively. You guys
How do
ready?
you put that in a calculator?
I'm going to show you right now. You ready? Come on, don't get ahead of me.
Sorry.
So this one right here, square root of 25, that cuts 25 in half multiplicatively. Now you have a square root symbol, right?
Yeah.
You should have a cube root symbol on there too, but I can't remember. Maybe it said
Go to, it's in
Ready?
math.
25. You ready? Ready? You ready? Sorry, I'm making you. It cuts 25 in half multiplicatively. The exponent would be multiplication, correct? So I want half of 25 multiplicatively. That's another way to represent the square root of 25. It's a 1/2 power. What does 25 squared mean? 25 squared. You would take 25 times 25. So I have 2 25s. 25 to the 1/2 power means I have half of a 25 multiplicatively, which is exactly what we just said, and I think you guys kind of agreed. You don't have to agree that that's what a square root does. It takes half of a number, something multiplicatively. So how do you think I would represent the cube root of 8? 8 to the 1 freaking third, yeah. Nice way to remember is that's a root, correct? Where are roots on plants?
Under.
Yeah, where's my bot? Is that one year I said that and somebody said, well, actually, you know, for tubers, the roots are on the, be quiet. Most plants, and look at me making fun of somebody else being a geek. Most plants have roots on the bottom, so that's where the root goes, yes? That's one way to kind of remember this, okay. How you guys doing?
You always put a 1 on top?
No. The 1 is there, to be honest, like what's the understood power on anything? If there's no power in something, what do I understand to be there? 1. So that's why that's a 1 up there.
I don't know how to use this.
You ready?
Yeah.
You ready? Put 8
8,
to the, you need your little caret,
caret,
parenthesis,
parentheses,
1 divided by 3.
1 divided by 3, close parentheses.
Enter.
Right, I gotta close it, right?
You could, yeah. Actually, it doesn't matter, to be honest.
Okay, I did that part, but the, like, the cube part is when I.
Oh.
You put a 3, and does that even?
There's a button. You see, the most intriguing button on the TI calculator should be the math button.
Math. You can turn any decimal to a
Math.
fraction, any fraction into a decimal, cube,
Oh.
more
There
stuff.
you
I
go.
don't even know what that.
Isn't there an nth root?
Yeah, there's an. It's X on the older models, and there's like F min, F max,
So
N
just to show you,
derivative, Fn int. And there's
just
no-
because.
There's so much on these calculators, I have no idea
Oh.
what they're even used for.
Yeah, so not as a cube right there.
Alright.
It should be.
Issue, alright. Come on now. Jeez, man.
Boom.
Yeah, oh, it's the next, yeah.
See, if I learned 1.
I want to show you this just because it's funny.
I should be good at math in 20 years.
There's so many these things.
So guys, let's say I want to do the 5th root of 32. Yes? Someday this is going to do what I want it to do, okay? Let me come out of here for a second. So in here I'm going to put second. I'm sorry, not second. Just go to math. Right there, math. Math is the button I would push first on the damn. I'm like, all of math is in, holy crap. Do you see this button right here, number 5? Number 4 is the cube root. Number 5 is intriguing. I call this the throot button. So let me show you what I mean. So come back out of here, hit second mode to quit. If you have a calculator, I'm sorry. If I do the 5th root, so I want to put 5, math, throot, so 5th root. See, look at that. Yours might look different if you have an older one.
Mine keeps putting answer on top, like
Oh, you have to put a number.
Put a number in first, sorry, yeah. Put 5 and then go to math. Tell it the root you want first. That's why I call it the throot button. So put a 5, it's the 5th root of 32.
and then the through
Did only work for 5?
No, it works for anything.
Whoa! Let's do
Well,
6
this
through.
is on 9, the X doesn't go away, but it still works.
Oh yeah. So if you have an older, and by the way, I'm really sorry for those of you that don't have a TI. It's fine. You're fine. But just to show, if you do have a TI, it might look like this. Let me see if mine does it. Like that? Yes.
Yeah.
That's
Okay.
what
And then you just put the number in. You're fine. So the newer calculators have what's called math print, and it's supposed to make it look like it would if you wrote it on a piece of paper. And sometimes it actually makes things a little worse, to be honest, but most of the time it's better. Okay, and you guys didn't see any of that. I'm sorry. Are they seeing anything?
Yeah.
Yes, thank God. Okay, that's good. Okay. So does everybody feel okay about if I gave a problem that was a cube root, you could attack it? Let's find out. So I would like to know what is the cube root of, what is it, Jeff? 343. Huh?
7?
How do you know that?
Wait,
Oh shit! I meant to do it by hand. Sorry. Damn. So the calculator's great. It's able to show you if you did something right. You're fine, Brittany. I didn't say it. You're fine. That was my fault. That's my fault. Damn. So what about, all right, so that's 7.
Do that by hand.
But how would you do this if I made you do this by hand?
Make a tree.
Is it even?
No.
No. So making a tree is a good idea, but I gotta figure out what goes into the freaking thing in the first place, right? It's not even, so 2 doesn't go in. There's 3 going.
Yes.
What's 3 plus 4 plus 3? Not a multiple of 3, so 3 doesn't go in. Do the last 2 numbers have 4 going? 4 doesn't go in. Does 5 go in? No. It's not even, so 6 doesn't go in. Yeah? 9 doesn't go in because it adds up to be 10.
And you never taught us the 7 rule.
7. So then you just start doing 343 divided by 7. So if you do 343 divided by 7, you get
49.
and then of course 49 is 7 times 7. So if I give you a problem with a large number in here, you start to try to break that thing apart. Because that's the whole idea. What does it take 3 of to make this thing? Well, if I can just break it down to its parts, I can see what it takes to make the damn thing. Okay, maybe Crockett. Okay, good. Blah, 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 blah. And something else that's in this section finally, excuse me, is algebra. So wait, I swear to God, there's something about this room or something. Talk amongst yourselves, I'm verklempt.
I've been smoking a pack a day for the last 15 years.
So just because I love math, I've already showed you guys some algebra throughout the semester. So if I ask you to solve this, how does that make you feel? Okay. What would you do first? Yeah. So the whole idea, the funny thing about solving equations is you try to unbury the x. X is just buried under all this crap. And you're like, I'm sorry, x. So you find, really bad joke there. You find where the x is, and you get rid of what's with it. One mistake students make, it's not really a mistake, it would still work. But I could divide by 2 first. But what does that make?
Weird decimals.
It makes fractions, which would work. It's fine, but I'm really good at math, and I'm not going to make fractions if I don't need to. You with me? Because that just makes a place for a human to make mistakes. So I've heard. So you add 1.
Divide by
And then divide by 2. I love it. Now, let me ask you this. Looking at the equation at the beginning, does anyone know what this number is in the first place? We don't know what this is, correct? Y'all, we don't know what 2x is. But it's a number that when I take 1 away from it, I get 11. That's what it says, correct? So another way to look at this, besides doing like adding 1, we just know whatever this number is, if I subtract 1 from it and I make 11, this number has to be, what number do I take 1 away from to make 11? 12. So that's a less algebraic way to look
Is
at
that
this.
the answer though? Like 2x
No.
is 12?
Well, 2x is 12, but the answer is
What are you talking about? What 1x is?
6. Because I always want to know what that unknown number is, right? Okay.
And the only reason you divided it was because there's a 2.
Oh, because there's a 2. So every step you take, what you're asking yourself is, why is x not by itself? Why is x not by itself?
X
So here's my x. Why is this not by itself? Because of the -1. So I add 1 to get rid of it.
Okay.
Why is x not by itself? Stupid 2.
Right.
What's the 2 doing to the x?
Multiplying.
How do I kill it? Opposite operation. Division. Yeah. So you don't have to teach such violent mathematics.
but eventually we have to learn.
I teach violent mathematics. I talk about killing things and so forth, right? Okay. All right. Let me see. How crazy do they get? They get a little tiny bit crazy. Let me see if anybody freaks out about this. How do you feel about that problem?
Like I'm back in middle school.
Ah, okay.
Middle school.
Dude, I swear my middle school was above what I should have.
Does anyone see why? All right, this problem looks horrible because it's got what?
Square root.
It's got a 3 square root of 7, right? Be careful. It's not a cube root. I gotta be really careful when I do this. That's a 3 times the square root of 7. That's gonna be very important in a second. What can I do on this side? Combine like terms. I love it. So what is 4x minus 7x? And what are you always asking yourself? When you're trying to solve an equation, you're trying to ask yourself, why is the variable not by itself yet? Why is the variable not by itself yet? So why is the variable not by itself yet?
-3.
Now, real quick. Yeah, sorry.
Isn't it easier to do the other side first though?
Say again.
Isn't it, I like to get it where I get the square root by itself,
Oh, if the variable was in here, yeah.
but like, you still can do it that way though.
Sure, but I don't need to square. That would be kind of going backwards.
No,
you
but
see?
if you divide by 3, it'll make -1x equal square root of 7, and then.
Oh, sure. In that case, in this case, it will.
Yeah,
But if there was an 8 here,
oh, then it's not as easy.
yeah. Okay. What was I about to say? Oh, I'm gonna make a mistake. Don't write this. And somebody tell me why this is a mistake. And then I'll have a student do this.
They're not like twos, they're not.
Because-
counting.
You don't have any 3s, you have 3 x's.
Good. What's the operation here?
Multiplication.
Can addition cancel multiplication? No. Okay. So that's why I try to tell my students, when you're about to cancel something, make sure what you're doing actually is the opposite operation. That's the only time something can cancel, right? So of course, what am I going to do both sides instead?
And I divide by -3.
Divide by -3. Yeah. What happens over here?
That gets to -7 squared.
Yeah, the 3's cancel, so you get negative square root of 7. So it looked horrific, but I did not have to do that much with the radical, right? It just kind of sat there.
Why did you not have to square it? Like, square everything at the top to get.
Because I'm not trying to solve for 7.
Okay.
Yeah,
You're just trying to find x.
I'm just trying to find x. X is almost by itself. Isn't all the x stuff on one side? That's the first thing I try to do in an equation, is to try to get all my x stuff on one side. So it's almost by itself already. So really quickly, just because this came up, this is a little more advanced than we have to worry about, but I'm certain somebody here can do this. How would I solve that equation? Why is the x not by itself?
That's being square root.
Because
It's inside of a square root. How do I kill a square root?
Square
Multiply by
everything.
3, multiply by 2, square it, sorry.
Square, yeah.
To get x is equal to 4.
So this is when you would square,
Yeah,
is
okay.
if you needed the radical to go away because your variable's stuck in it.
Okay.
So I like to think of this as a prison break, right? Get out! Ah! So now he's out, and I got 4 over there. Now, of course, the funny thing about very basic equations is, if you just stand back and see what the thing is saying, what does that say? What does that say? The square root of
Blank
some number
is
is
2.
2. So of course I know the number is 4. I don't have to do algebra to figure that out, right? So you can see that. So for very basic equations, I don't really have to do algebra. I just kind of like, what's it telling me? Okay, it's this. When there's a lot of shit happening, I can't do that well.
For that problem, why, can we go back to the point where we started dividing instead of, so we know 4 and 7, they're like terms, that's why it gives us.
Yeah, the x's are like terms, yeah.
And then that stays the same on the other side, 3. Why did you divide?
Oh, so we got to this point here, As I'm solving for a variable, what am I always asking myself? Why is that variable not by itself? Why is that variable not by itself? Why is that variable not by itself? Why is the x not by itself?
Because it's being multiplied by -3.
So I'm going to kill the -3. If I can get the x by itself, whatever's on the other side is the answer. That's what the x is. I love it. You would, Jeff. Okay. Okay. Last little thing. This is the very last new thing for the whole semester. It's a very momentous moment.
Kind of a big deal.
This magic moment.
Back to the Future soundtrack.
Yes. It's not really what I was thinking of, right? Oh, I totally forgot what I was about to do. Oh, yeah. That's right. Can somebody tell me? So watch this. I'm building up to algebra with inequalities, but I want to show you something. Oops, make this -2. Can you tell me which one of those is bigger? How would you draw the inequality symbol? This is not a major question. It's not a gotcha question. Just which one's bigger? One. I like this one. So one's bigger. If I divide both by -1, what do I get? 2.
-1.
Which one's bigger now?
2.
What'd the sign do?
Surface a lot.
Okay, so, you guys with me? Remember, this is what I was talking about last time. This is one reason why I do it. When I multiply by negative, I change what side of 0 I'm on. So whatever was bigger is now smaller. Whatever was smaller is now bigger. So what does that have to do with algebra? Nothing. No, it does. If I have this, what do I have to do to both sides to get x by itself? Divide by -1, yeah? Remember, there's always an understood 1 there. So why is the x not by itself? Because they're done -1, so I'm going to kill it. But if I do that, that's got to switch. Let me show you why. Let me show you the long-ass way to do this that I never want you to do, but you'll see why. You with me? Everybody cool with this? Everybody really get this? Why is the sign switch? Because it does. That's the one damn time of a whole career I could just say, because it does. It's awesome. Why? Because. All right. I'm going to resolve this in the dumbest way possible, but I'm going to do it because it just shows you what's going on. Before I do that, a little side note. If 7 is less than x, x is greater than 7. Is everybody with me on that? Does that make sense? Okay, beautiful. So watch this. I'm going to go crazy, right? I'm going to add x to both sides. What's -x plus x? 0. Now I'm going to subtract 3 from both sides. Now I'm going to do what I just did over there. If -3 is greater than x, x is... If -3 is bigger than x,
X is less than -3.
x is smaller than -3. Isn't that the same? So, if I add this to this side, doesn't the x change the side it's on in relative to the sign? So if I take a shortcut and a divide by -1, that's got to flip to match up with what it would do otherwise. Okay. Maybe? Sort of? Do you guys remember that? That's the one thing that killed people on inequalities, because everything else about solving inequalities is exactly like solving equations. You get your x's on one side, you get your like terms, you divide, blah, blah, blah. But if you divide or multiply by negative, you got to switch the sign. With an equation, and here's a real quick stupid little thing. If I have an equation and a divide by -1, and I switch the sign, it still looks like a freaking equals, yes? So it doesn't show up. So you can pretend like we always switch the sign. So if I turn an equal sign, it looks the same. Okay. All right. That was even done for me. That's okay. I like it. Okay. So for chapter 8 in section 9.2, you only have to do set B of the homework. Section 9.1 is extra credit. There's no real reason to do it, so if you want to do it, you get some bonus points, but it's fractions again. The way I work is if you do all the homework and you do like one section of extra credit, you get above 100% homework grade.
But you'll just.
So it'll factor into your overall grade. Does it make sense? So if you have a less than 100 homework grade and you do a section of extra credit, it'll bring your homework up. It'll take the place of like a missing homework section or something. You guys kind of with me? Okay. All right. Okay, so that's it for the new stuff. Here is the practice final. What do you mean, one pass questions? Oh, that's the bonus
I have
question.
this except.
Oh, I.
They give everybody one? Missing.
So 7.3 and 9.2 is what's
Say it one more time, sorry.
the homework due is 7.3 to 9.2.
Yeah, and
And then this extra.
that's extra credit, yeah.
But just B?
Huh?
Just B, not A?
Yeah, you just have to do B, just to make things a little better here at the end. A little bit easier to keep up with before the final. Our final's in a week, so.
Will you have to do B for all of them?
For chapter 8 and section 9, 2, yes. So you only have to do the set B if you want to. Yeah.
Not 7.3 or 7.4.
No.
So we don't do 7.3 or 7.4 at all?
No, yeah, do 7, 3, and 7, 4, yeah.
A and B?
Yeah.
Oh, okay.
I do not remember how to do some of these things.
Yeah, so let's take a look at the practice final. Let's I kind of want to start the review today, since there's a lot that could be on this final. Yeah, this
Are we gonna get
final's not going to be this long.
Are we gonna get a cheat sheet for the Egyptian, Roman, Mayan, and Babylonian?
Yeah, anything I allowed you to have before that I included is going to also be included on the final. So the Mayan base, the Roman numerals, what else was the Egyptian numerals? That's going to be on there. Was there anything else?
Babylonian stuff and all that.
Babylonian you had to know.
Yeah. That was base 60.
Are we gonna have all that on there?
Everything I gave you before, you're going to get it again. That'd be so evil if I'm like, no, you must know it. No. So the Egyptian numerals, the Roman numerals, the Mayan base I gave you. I made you memorize the pancakes and blueberries, or whatever you want to call them, right?
Yeah.
I made you memorize the Pac-Man and the stick.
Are we allowed to use 0 for Babylonian?
There is a symbol for 0. I think the book did show it. Off the top of my head, I can't remember what it is.
It's
But
the double upside down triangle.
yes. Yeah. So you could if you want to. That's the Mayan.
That's the Mayan.
The Mayan's got it looks like a bun or something. Yeah. Okay.
Is it just gonna be like every other system front and back?
Say again?
Not like a package?
Huh? Yeah, it's basically going to be, how much time do we have for normal test?
The period.
2 hours.
About 2 hours. So this is going to be the same length of time. So it can't be
That's true.
longer than like, just do it faster. No. It's just the fact that it could have anything on it. Yeah.
Number 5 says page 82, number 5 is that in the book?
I think so. Let's double check. Let's see if Jeff
See if Jeff did math right.
did Jeff math. It looks like Jeff math. Dude. Oh yeah, that makes sense. That's the Egyptian and stuff. I just didn't feel like copying and pasting like I did on the test, so. It's in the chapter test, so I was like, that's perfect. You guys can do that. Let's see. Oh, I forgot to change that. So just to really highlight the fact that I can't count, there's 2 6s and 2 7s. I was gonna fix that, and I guess I didn't. It's too bad. On the practice final, did you guys see that? Yeah, that's good stuff.
Sorry.
That's good stuff. On the practice final, it says 5 6 7 6 7 8.
Are we reviewing right now?
Yeah, it's wide open now.
Let's begin.
And so it begins. No, yeah, of course. So on Thursday, I'll have the answers for this. Yeah. Yes.
What would be the formula for number 1? Trying to express two counting numbers equal an odd number?
Oh, how do you represent an odd number? Who remembers? What's true about every even number? Let's start there.
Divide by 2.
So how can you represent any even number?
N times 2.
Beautiful. Every even number has to be 2 times something. Does that make sense? 2 is 2 times 1. 4 is 2 times 2. 6 is 2 times 3. So how do I write any even number? 2n.
So
How does an odd number relate to an even number?
That it has a plus one or minus one?
yeah.
Good. So real quick, if n starts at 1, this is 2. N equals 2, this is 4, yes? So it would be minus 1. So that if n is 1, this would be 2 minus 1, that starts off at 1. If n is 2, this is 4 minus 1, that's 3. So I'm going to pick up all the odd numbers, correct? So my question is, show that every odd number can be expressed as the sum of 2 consecutive counting numbers. So let's see, give me a counting number. M, there you go. What's the number, good Lord, what's the number right before that?
M minus 1.
M minus 1, good. So everybody with me?
Minus one is the number before any letter, right? Like
Yeah.
Yeah.
If I give you a number, good Lord. All right, everybody, give me a moment. God, okay. Any time I have a number and take one away from it, it's the previous number, correct? So would you guys agree that these two numbers are consecutive?
Yes.
Yeah.
Consecutive, meaning they come right after each other. What do you get when you add those together?
Odd number.
What do you get exactly? Add these together.
2n minus 1.
Yeah. You get 2n minus 1. Isn't that the form of an odd number? So try this. Give me a number.
9.
Give me the next number.
10.
What's 9 plus 10?
19.
So this is getting a feel for the problem, giving values for the unknowns, just to see if it makes sense. Any two counting numbers that you give me, if you add them, it's going to be odd. That's the idea.
Yeah.
I didn't really necessarily mean to do that whole thing, but I can't stop myself. I should have left something for you to do. It's too bad.
So, because I was thinking of writing like 3 plus 4 equals 7, 7 plus 8 is going to be 15. That's basically what we're getting at, right?
Do it again.
3 plus 4 would be 7.
Good.
Like 7 plus 8 would be 15.
Yeah, so it
Plus
seems
3.
like it's true.
Yeah.
But the only way to prove it is to do it for every possible number, and that's when you bring variables in, right? So that's the old solve these variable from chapter 1. So one way to kind of do this is to use the final as a gauge, and you either do the problems and see which ones you have the most trouble with and then go back to the sections, or you glance over this and go, I really don't remember that worth shit, then you go to that section before you try to do the practice final. Are you guys kind of with me? So today I just want to do a couple of things that jump out at you. If there's any of this stuff that you want to kind of
Yes.
go over. Yes.
3A, the under one means or, over means and
Good, because I always remember like this, like you or you, I don't care. Somebody do this.
and the top one means like not, like anything
Good.
other than.
Good. It means not be. Something in the universe that's not be. Yes.
Can we do base conversions?
Sure. Yeah.
Using different numbers.
All right. So I'm going to leave those for you guys to do. Let's do a problem like it. So let's say I want to convert 1149 to base 9. That means the highest digit I could use is
8.
8. So, here's the thing, the biggest mistake people make with this kind of problem is they do this backwards. If I do this, I have really obviously made a mistake. Number one, I don't know what the number is in base 9, so I'm not in base 9 yet. And number two, this can't be in base 9 because it's got a 9 in it. Yeah? So, in fact, it's really bad because I just put 9s down there for some reason. So 1, 9, what's the next place?
81.
81.
Looks like 180.
You ready? 8 times 9 is?
6561. Oh,
No, you went too far. I think you did the next one, maybe. I don't know.
7.
Multiply by 9, right? Multiply by 9, multiply by 9.
no.
Yeah, you got the next one.
And the next one was 6,500 something?
65, 65.
Now, real quick, you guys remember this? How are we doing so far? So, base 9, you always have a ones place. Multiply by 9, multiply by 9, multiply by 9, until what?
Oh, until you are over the.
Over this. So I know this is far enough, right? So how do I do this? What's the process?
Now you divide 729 by.
Good. So how many 729s in 1149? You can tell that's just one of them, yeah? Because two of these would be 1400 something. So then you do 1149 minus 729. So how much? So this is taking care of 729 of this number. Now I just want to see how much of the number is left.
420.
420.
And 420 goes into 81. 5 times.
Yeah, so this would be 5. 5 times 81 is 405.
405.
You guys, is this coming back?
Yes.
It's like ride a bike without any pedals. And then 15,
Yeah, and then 1,
1 9,
and then 6.
then the 6 ones. So this would be 15, 16, base 9.
And that would be the same process for any basis.
Anything. The one thing you have to be careful about is if it's a base higher than 10,
Yeah.
what do I have to use sometimes?
A,
A, B, C, D, E, whatever. Yeah.
So A would be 11. A would be 10.
10.
11 would
B.
be B. 12.
C is 12. Yeah, good.
It's like writing.
You go ahead and apply.
Yeah,
Yes.
number 2, I just wanna see if I'm right.
What'd you do?
You add 3 is the sequence?
For every other one?
No, like 3 plus 5 equals 8, 5 plus 6 is 11.
Oh, it's interesting.
That sequence, and
All right, so let's see. 3 plus 5 is 8. So 3 plus 5 gives you like
8 on the
2 places later. 5 plus 6 gives you 2 places
11.
later. Neato. That's not even what I was thinking.
Oh.
So then what would be your next thing?
6 plus 8 is 14.
So your next thing would be
Just
14.
keep adding them, and then
All right, this is exciting for me. All right. Everybody, stop what you're doing. Look at number
What did you
2.
get for your answer? Did you add 11 and 14 or?
I got
Hold up,
12
hold up,
and
hold up.
14.
Okay, yeah, cool.
I love you guys. Somebody else did the same thing? Oh, that's so cool. All right. That is not what I intended for this problem. Which does not mean you're wrong. It just means you're beautifully right.
You're even more right.
3, 5, 6, 8, 9, 1. It's not easy to come up with an example. I think I told you guys, if I don't give you enough information, so if I said 1, 2, what's next?
4.
Could be 3. Or it could be 4, right? Because maybe it's powers of 2. It could be like almost, you could argue for almost anything because I haven't given you enough information. So in this problem, I thought I gave enough information to be a very specific thing I had in my head, and then Linda comes along and says, no, you're crazy. This is what it is. I'm like, oh shit. So, not a damn thing wrong. If you did that, beautiful. Tears, no points off. So what, Linda, you tell me again what you said. You said
3 plus 5 equals
3 plus 5 equals 8.
and then
5 plus 6 equals 11. So to get this number, you would do 6 plus 8, right?
Yeah.
Yep. So you would get 14, right? And then to get this number, you would do,
I didn't do it that way. I lined it up vertically,
Oh, but still, did you get 14?
Yeah,
Let me make sure I'm doing it right.
No,
3
no,
plus
I
5
got
is 8.
12 and then.
5 plus 6 is, oh, you skipped 2 numbers. Okay, now I'm getting a little less excited.
Down to 9.
So, this doesn't quite work.
Okay.
The answer should be 12 and 14.
No, I'll get there. So I'll tell you what I had in mind. Okay. Alright, so if you do 3 plus 5, you get 8.
Yeah,
So you skipped a step, right? Which is fine. But then 5 plus 6, now you gotta skip 2 things to get to 11. You see that? So it's a little bit, that won't sustain itself. You're gonna start to have gaps in the middle. I love the attempt.
I did plus 2, plus 1.
Yeah! So what'd you do? Plus 2,
Plus 1.
plus 1, plus 2, plus 1, plus
uh,
2, plus 1, plus 2. Yeah.
Yeah,
That's
did
what
it.
I had in mind.
I got the same answer, 12, 14.
Oh, you did? So how did you do that?
So, line it up vertically,
Alright, so 3, 5, 6, 8, 9, 11.
and then 3 plus 5, right it to the side is 8. And then the next is 5 plus 6 is 11. And then it goes 14, 17.
Oh, you,
20.
oh! Okay, now, I'm sorry. So you did adjacent sums and saw that they were always off by 3.
Yeah.
Okay,
And then so you.
so 3 plus 5 is 8, yes?
Yeah.
5 plus 6 is 11. Yes?
Yeah.
6 plus 8 is 14. Aren't these 3 apart?
Yeah.
Every time? You guys are clear with me?
Yeah.
So now I'm excited again, I'm sorry. So then the next thing, when I add it to 11, has to make
20.
20.
And then if you add
Wait a minute, what?
3, because the sequence is 3, it's 23.
Oh, I'm sorry, I skipped one. 9 plus 11 is 20.
Yeah.
Okay.
And then if
So the next thing has to add to be 23, so of course that would be
23
12.
minus 11.
Yeah. Now, here's what you did. This is so cool. Plus 2 plus 1 plus 3. So Linda was like, I'm not going to take your little piddly steps. I'm going to take one big ass step of 3. Thank you
Big
very
boy
much.
steps.
Which is beautiful. So you end up getting the same sequence. You just looked at it in a different way. Tears. I need you to understand. This is exactly beautiful for you guys. This is why you can't immediately shut a student down when it seems like they did the wrong thing. Because they could have done something that was creative, that was sort of coming back to the right thing, or is a different way to look at the problem you gave them.
Sure.
You with me? So I love that. Thank you. Okay.
Okay, 6.
Oh yeah. So you know I'm going to give you problems like this, right? This seems to be one of my favorite kind of problems to give you, which only makes sense because this is going to be most of your job, is trying to interpret what your students are trying to do.
Well, there's 2 6s, what 6 are you talking?
Oh yeah.
That's very true.
The second 6?
2, yeah.
Yeah, the second 6.
Not the base one.
Yeah.
Yeah, the second 6.
Yeah.
A student starts
Good old Jeff
following
showing
the
off.
following work. How
I
do you
always know my
explain
numbers.
to them that they fucked up?
I
You
don't
do.
think you can say that to a child.
You said, listen to me. You fucked up. But
I'm gonna get you right, Tim.
I want my dean to watch this video specifically. Jeff?
Don't call him Timmy can't get right.
Alright guys, so does anyone, don't tell me, but on number 6, if you look at number 6, can you see the mistake that was made? And a really smart idea, when I give you a problem like this, what's the mistake that was made? Just do the problem yourself. And then look back at what they did, right? So what you got, Shayna?
They multiply like 1 as in the one place volume, not in the things.
Beautiful.
Yeah, they
So
multiply
the 412 they got
Mhm.
should be what?
Scooted over.
Scooted over.
Oh,
Beautiful.
add 1 0.
Yeah, add a 0. This should be scooted over.
I don't-
So, huh? Sorry?
I don't know what I'm looking at. Like, what is the problem? 'Cause
All right. So it's 412 times 12, yes.
Okay, because I see a plus.
412 times 12, yes.
Yep.
Now, how would you do that?
I would 2 times that.
Yeah, 4, 2, 8. Do you see 824?
Yes.
What would be your next step? What would you do next? Don't look at that anymore. What would you do next?
For what?
To keep going, you got to multiply by 12. So far,
Oh,
you
I'm
multiply by
sorry.
2.
Yeah. I would 1 times 2.
Where?
Okay, now I'm confused. I'm the student.
No, I'm sorry, I'm putting you on the spot a little
That's
bit.
okay.
So we would put 1 times 2, we'd put it here, yes?
Yes.
So sometimes we put a 0 there and then we scoot over?
Yes.
Okay, right? It's really weird, right after you look at a problem and you're supposed to tell what's wrong, your brain kind of does this thing where it's like, I don't know, I just looked at it, it looked fine. You with me?
And then add.
Now why? Yeah, then we would add it, but why? This student gets about 75, 80% of this process, which is great. You don't want to knock that. They got one little thing that is really kind of like forgivable. Like, yeah, I get it. You're right. It's a freaking 1. Why wouldn't it be? But it's not really a 1 though, is it? It's a 10. So this is where you would go back to an earlier algorithm that you would have used. And you wouldn't say the word algorithm, but how would you first introduce doing 412 times 12? You would do 412 times 10 plus 412 times 2, yes? Right? Which leads to exactly this. Because what's 412 times 10?
4,120.
4120. And 412 times 2, 824.
So why did you write a plus 4,112 on the bottom?
Because that's what you're supposed to do next, yeah. You're supposed to add, like you told me, you're supposed to add those, yeah.
You can have 8.
If A is an even number and 7 divides A, does 14 divide A? I like it. You would, Jeff. So remind me, what's the rule for 6? Divisibility rule for 6.
2 and 3.
2's got to work and 3's got to work. So why is the divisibility rule for 8 not 2's got to work, 4's got to work?
Because 8 works different.
Because 2 and 4 are not
Something prime.
Prime.
something prime. They're not
Relatively
something
prime.
prime. They're not Optimus Prime. They're not relatively prime. If 2 divides into if 4 divides into a number, doesn't 2 automatically divide into the number because 2 is a part of 4?
Yeah.
Yes? So if they are not relatively prime, I can't just say if both rules work, then the product works. That's why 6 works. Are 2 and 3 relatively prime? Yeah, in fact, they're actually just prime. So they're automatically relatively prime. So if the rule for 2 works and the rule for 3 works, 6 works. Now look at this. What should the rule for 14 be? We can make a rule up. You can make up rules all day.
If 2 and 7.
If 2 and 7 work, because are 2 and 7 relatively prime?
Yes.
How do I know 2 works?
Even.
Because I said it's even. And how do I know 7 works?
7 and 14.
Because I said it works, right? So if 2 works and 7 works, does 14 work?
Yeah.
Yeah, totally.
So we'll just pick yes.
No.
You have to explain why.
Yeah, you have to explain it.
So for 2, put yes and then even number, is that fine for the answer?
So, all right. I don't want to lock you into one way to answer this, but because there's a lot of different ways. You got to capture everything I just said, but A is even, correct? So if A is even, what's that mean? Here's the way I would do it, which is not the way I think some of you guys would like to do it, because I know I'm a math guy, so I do things very mathish. But I would say this means this. 7 divides A, which means A is 7 times something, yes? Are you guys with me? So A has to have a 2 and a 7 in it. So A is actually 2 times 7 times something. So does it have a 14 in it? Yeah. So you don't even have to do this mathish. You could say A's even, so it has to have a factor of 2 in it. 7 divides A, so it has to have a factor of 7 in it. So of course it's got a factor of 14 in it. Does that make sense? Now, on the side, let me show you one that would not work. If I told you that 4 divides a number and A is even, does that mean that 8 divides the number? If 4 divides the number, it's already even, right? Do you guys with me? If 4 divides a number, doesn't 2 already divide the number?
Yeah.
This is why they have to be relatively prime. If 4 divides a number, what does that mean? If 4 divides a number, doesn't that mean that 4 is a factor of A?
Yes.
Isn't 2 already a factor of A? Does 8 have to be a factor of A then? No. That's it. Here, 2 is a factor of A, and 7 is a factor of A. They're relatively prime. If it must have both of them, it must have 14 in there. It has to. Can you guys come up with a number that's divisible by, how do I say it? Yeah, divisible by 4, but not divisible by 8.
4.
Yes, 4 is the easiest one.
12.
12. 20. 28. Yeah. You guys kind of with me? So that's basically what I'm saying over here.
22.
No, 22 is not divisible by 4.
44 probably.
Yeah, it'll be halfway between multiples of 8. Will be something that 4 goes into that 8 doesn't go into.
The GCF using subtraction.
Oh, sure. Let me do one like that so I can leave one for you guys to do. What time is it?
Oh, yeah, plenty of time.
My target for today, by the way, is to let me out early, which means let you guys out early. You guys get to
And we still
benefit.
review in the next class, right?
Of course, yeah.
Yeah.
Yeah, this is just the beginning.
That's the 2-hour study period.
We have a board meeting tonight, and
Yeah,
we're going to do public comment talking about, you know about it?
I'm just kidding.
I was going to say,
Just
holy
felt
shit,
like
he's
it's-
on to it. All right, he's in the know.
Hell yeah.
Talking about the AB 75, the stuff that killed intermediate algebra, and they're trying to kill pre-calc, so we're going to say some stuff.
Don't kill pre-calculus.
Yeah, we'll
Tell them there's kids like me. We need all the pre's.
What was the question again? GCF?
GCF of, let's go with like 904 using subtraction.
484 and 52, sure. Okay. So I want to know that GCF and I want to use subtraction.
So we would start by doing 52, or 484 minus 52.
Yeah, so here's a way you can kind of truncate this a bit, which I will allow. I could subtract 52 several times, correct?
Yes.
So let's subtract, I can subtract it in groups of 2 of these. That would make this a little bit quicker. You guys with me? You goose? So this is subtracting 2 52s. Is that cool? Because otherwise this would take me a while. You guys agree?
You pick those numbers, we didn't.
She has a point.
So my point really is, I'm gonna give you something like this. So I'm trying to show you, if I was a student and I gave this to you, what would I try to do to make this a little bit quicker? Now I could have given myself an easier problem, and then later I could have, now you guys get to do the hard one. So what do I get here?
380.
380, right? So far I've got 2 52s. Keep going. 276, keep going.
172.
172. Can I do it another time?
Yes.
Yes.
It's 60.
68. So now let's see what I got. So now I got, this is equal to the GCF of,
You can do one more 52.
Oh, yeah.
yeah, I can do one more 52. Yeah, that's a good point. I forgot.
60.
60. So now this is equivalent to, I took 44, made it 60. So now I can do this. 52 minus 16 is, in fact, let's do 2 16s, yes? 52 minus 2 16s is
20.
20, minus 16 is
4.
4. So I made this, let me stop for a minute. You guys kind of with me? I took 44 and I subtracted it down as far as I could, subtracting these, and I got down to 16. So that I replaced 44 with 16. Now I do the same thing again. Now I start with 52 and I subtract it down and I got it to 4. Can you guys just tell me the GCF is 16 and 4? 4. Done. So the whole idea of that is, if 4 can go into 2 numbers, it can go into the difference between those 2 numbers. Give me a number 4 goes into, kind of a biggish number, 2-digit number. 4 goes into, that's a 3-digit number, that's okay. 76. Give me another number 4 goes into. 76, another number a little bit below 76. That 4 goes into. 44. What's 76 minus 44?
Number divisible by 4.
True. 76 minus 44 is 32, divisible by 4. So of course that works, because 4, 8, 12, 16, aren't they all separated by some multiple of 4? All the multiples of 4 are separated by a multiple of 4. So that's why this works. If I subtract each of them from each other, it's going to maintain the answer. It's going to maintain what number goes into both. That kicks so much ass.
Okay, so on the math problem, it's 540 with 300, so 540 minus 300 is 240. Can we just knock off some zeros and do 54 minus 30?
No.
No.
So what is it? I'm sorry. I'll do a couple of those. 540 and 300? So you can do this without even doing this whole subtraction, because you can only do 1 300, so that would become 240 and 300, yes?
Yeah.
All right, so now subtract 240 from 300 and you get
60.
60.
And then you,
Now, can anyone see right there what number goes into 60 and 240?
60.
60.
Oh, yeah.
You can keep going. You can keep going. Subtract 60.
That's 4 hours, so yeah.
Subtract 60. Subtract 60. Now this is kicks ass. What's the GCF of 60 and 60? 60.
Okay.
So you really just
You do it until you can see it. You
kind of
do it until you can see it. Huh?
you kind of just like boom.
Yeah, you're using the other number to cut this number down to size. Using the other number to cut this number down to size. And because you're subtracting the 2, whatever goes into both is maintained. I don't know if you guys are really with me.
So will this change if you're trying to find the greatest common factor of 3 different numbers?
No, you could do the same thing.
It's just a
Well,
little
you'd have to
complicated.
adjust it a little bit, yeah. But we didn't do that, it's okay. What do you guys think? Can we call that and then pick this up Thursday?
Yes,
Is that all right?
yes.
Okay.
And then we can review the other half.
I love that.
We're gonna be all right, guys.
We're gonna pass.
We're gonna be all right.
I need to get like a 40 on this test and I'll be happy.
It's all right. I'll have the answer key for the practice final Thursday.
I need like a 40% to pass the class. And like a 70 to get it with a B minus.
All right.